Hello everyone, so today we are going to do Leetcode daily challenge. Find the corresponding node of a binary tree in a clone of that tree. So basically in this question we would be given with a binary tree and also a clone version of that tree. Basically two trees would be given to us in this question, and earlier I was saying that I need to clone this tree also, and it would be something like it would be directly that question only, then cloning a tree and so on. But the thing was, in its function itself, we were directly given with the original tree also and the clone tree also. So in all that context, what we are required to do is we are required to traverse both of the tree at the same time, and then we are simply required to check that is that particular means this target node. If this target node has been reached, then at that particular moment only we are required to return the reference to that target node from the clone tree rather than original tree. So this is all about this question and what is required to be done in this question. The thing is that you are given two binary trees, original and clone, given a reference to a node target in the original tree. So this target, it's basically the reference in the original tree. Means this particular node which would be given, it won't be the one which is being into that clone tree, means reference in that clone tree. It is not there, but it is a reference which is being in the original tree. So saying is the clone tree is a copy of the original tree. That's true, but now what we are required to return? We are required to return a reference to the same node. Means basically this target node, which is a reference to this original tree, but now we are required to return the reference to this clone tree. So note that you are not allowed to change any of the two trees of the target node, and the answer must be a reference to a node in the clone tree. So this is about this question. Now let us see about the time curve, the constraints which are being given. So the constraint here at up to 10 raised to power 4 and minimum it would be 1 about the number of nodes. But a tree is a binary tree, so the thing is if it could be a complete binary tree, so its height could be maximum log n, right? And if it becomes a skew tree, the way it is here in this example, then the nodes would be till 10 raised to power 4. Means order of n traversal. If it is being done, then also it would be fine. Not a case for TLU also here. And the values of the nodes of tree are already given. And now the target node, which is basically here, it is from the original tree and it is never null. So these are the constraints which are being given to us here. From these constraints only two things we could check, that the reference is from the original tree, and the second is that as the considered till 10 is proposed, so yeah, it could be till order of n. That's the thing here. Now let us first check that how it could be done. Okay, so the thing is that our original tree is being given and the clone tree is being given to us, same as the first example I have taken here, and we are required to find this. This is original tree and in this clone tree. So the thing would be that only thing which we are required to do is traverse both of trees together, as I've told earlier only. And when target is reached, basically this tree has been reached, then we are required to return reference to clone tree, means reference of this particular target in the clone tree only. That's the thing which we are required to do. So another thing is that what need to prefer for the traversal, because traversal of a tree could be done by BFS or DFS, by any method it could be done. So yeah, here also any method could be preferred to be done, because the space complexity and time complexity for the both of them would be same here. Because of the fact that if we are doing BFS, then would be choosing in zigzag manner only, right? Level by level we would be doing it, and if the target it is at the top only, means if it is in the right hand subtree and it is on the top side, right? DFS would work faster, provided it is a dense tree. But if it is a skew tree, right, then in that case, if we take, then again we are required to traverse level by level. Although in that DFS would also work faster, the thing is like somehow both of these solutions would work equally as, as in context of time complexity and space complexity, because if we are using this DFS, then cube would be simply used so for storing, and in this DFS the recursive stack would be used, and we don't know the position of the target where it could be. So, and even we don't know that it is a dense tree or a skew tree. It could be any sort of tree, right? So that's why we could use either of the solution for this question. So now I have done with the in-order traversal only. So now let me show you this solution, how it works here. So basically, in this solution, what we are doing is this is that particular original function, and then this particular answer and target which are being there. And now what we are doing is, rather than passing target in this function, just created a global private variable so that we could access the target here also, and we are not required to pass here as parameter. So just reinitializing it here, it is private. Now in order, we are passing this original and cloned. So while passing this, what we are doing here is, so if our original exists, right? Then what we'll do, we'll simply do the in-order traversal while passing originals left and clone left, because I have told that both of the trees are required to be traversed at the same time, right? So that's why both of them are being passed, means both of the left subtrees and then here right subtrees, and here whatever processing would be there, because it is in-order traversal. So the processing would be something like if original equals to target, right? Because the target is basically the reference to original node, original tree only, right? So that's why both of them are equal, and what we are required to do is this clone, whatever would be present at that moment with this cloned tree, we would be required to pass that reference only to this answer, because this answer is also a pointer only. So whatsoever would be assigned to this clone, it would be directly copied to this answer, and thus we could return directly this as our answer. Yeah, we would be directly returning here, because this is the return type of word. So whatsoever we would be making changes in our answer, so it would be directly returned here. So this is all what we would be doing in this particular for this in-order traversal, right? And the time complexity would be simply order of n only, because we are simply traversing this tree, which could be even a skew tree. So when it would be a skew tree and our target is basically here, then we would be required to traverse all the n nodes. So that's why time complexity at max could be order of n, but it could be also log n also. Then the case would be something like this, means basically the time complexity is about the height of our tree, right? So in this case our height would be log n, but in this case our height would be n. So that's why at worst case our time complexity would be of order of n, and at average case it would be order of log n. So basically this is being determined according to the height, that is our height could be n or our height could be log n. So according to that, a time complexity would be, and the space complexity would be again according to the maximum number of nodes which could reside in our queue or recursive stack. So again, it would be order of n, or it could be even order of log n. So in that context, again, the space complexity is again directly according to the height only. So yeah, both of the means this time complexity and space complexity both are same basically here. So that's why it is order of n only. So this was all for this particular question. If you have any doubt, you could comment that down. So yeah, thank you.